Okay, we're reacting sodium and chlorine together to make sodium chloride, table salt in this reaction. And we're taking 6 moles of sodium and mixing it together with 4 moles of chlorine. And they would like for us to predict how many moles of sodium chloride are produced by this mixture. Using the power of stoichiometry and those mole ratios from our coefficients from our balance equation, we should be able to predict the quantity of product made anytime that we're given quantities of reactants. But I don't have a picture in front of me. I can't circle sets and visualize how much product is made. So we're going to have to construct a full BCA table, which starts by writing your balanced equation at the very top. B stands for before, so the quantity of each reactant that we have before the reaction begins. Based upon the question itself, we have 6 moles of sodium at the beginning of the reaction. We have 4 moles of chlorine at the beginning. And it is assumed that 0 moles of product are present at the beginning of reactions. Now for the change row, or your coefficient row. This is where the limiting reactant comes into play. You don't know which one the limiting reactant is. You don't know if it's sodium. You don't know if it's chlorine. So when you get to these situations, I want you to test the first reactant and label it as a limiting reactant. Not saying that it is going to be the limiting reactant, but we're going to see what would happen if it was the limiting reactant. So limiting, we know, means all of it is used. So if we start with 6 moles of sodium, limiting would mean that all 6 moles of it is used. So I know I'm going to copy that 6 to all the other columns because the limiting value gets copied over and over again. We minus 6 for the chlorine because it is a reactant, but we plus 6 for the sodium chloride because it's a product, because it's being made. So now we're going to multiply all the other columns, everything but your limiting column, by a mole ratio, which means that fraction. The fraction comes from the coefficients. Since I am going to solve for chlorine, I'm going to put its coefficient in the numerator. So the column that you're in, what you're solving for, in this case the chlorine, the coefficient of that compound goes in the numerator. So chlorine, its coefficient is 1. So I'm going to put a 1. And then sodium, since we're assuming sodium is our LR, our limiting, its coefficient is 2. So I'm going to put its coefficient of 2 in the denominator. Okay, the limiting reactant always goes in the denominator. So real quickly, we're going to do some math. 6 divided by 2 gives me 3. And I pause. This is when I determine if in fact sodium is limiting or not. Chlorine, we start with 4 moles of chlorine available. And you look at the change for the chlorine. 3 moles of chlorine are needed to complete this reaction. So do you have enough chlorine to complete this reaction? The answer is yes. You start with 4, but you only need 3, so that means yes, this is going to be extra chlorine left over, meaning that sodium, yes, is your limiting reactant. So since sodium is limiting, I'm going to proceed with the rest of the problem. For the sodium chloride, its coefficient is 2, so its coefficient of 2 goes in the numerator, and that denominator is always the coefficient of the limiting reactant. So my limiting is sodium. Its coefficient is 2, and I solve this one. 2 over 2 really reduces down to 1 over 1, so this is plus 6. For the after row, it is the before combined with the change row. So for sodium, 6 moles before minus 6 of the change, that gives me 0 moles. Hence, it is the limiting reactant because it's 0 at the end of the reaction. Chlorine starts with 4 minus its change of 3. You get 1 mole of Cl2. And for the sodium chloride, it starts as 0 and you're adding 6. You get 6 moles of sodium chloride produced. Just as emphasis, I'm going to highlight, and I want you to do the same as well. Highlight that limiting column because everything depends upon that limiting reactant. I know that the sodium is limiting because it's the one that's 0 after the reaction. And its coefficient was very important. Its coefficient of 2 was copied to the denominator of all the mole ratio fractions. And also, its starting value of 6 was subtracted. Okay, all of it was used. That 6 was carried over to all the other columns. That value of limiting reactant is used in all the other columns for your reaction. So, part A, how many moles of sodium chloride are made from this mixture? Your answer is right here in your BCA table. Go to the after row. We made 6 moles of sodium chloride. And really, I should pay attention to sig figs. It's 2 sig figs based upon the givens. 6.0 moles of sodium chloride are made. Part B, what is the limiting reactant? Well, we said that was the sodium. Lr equals sodium. And part C, what is the excess reactant? The excess reactant, first of all, has to be one of the reactants. And it's the one that you have extra of. The one that is not 0 at the end of the reaction. So that is going to be our chlorine. We have 1 mole of chlorine left over that did not react. So our excess equals Cl2.